Hello, this is Paul from Foresight Tech. In this lecture, we are going to deal with the polar curve using calculus. The polar coordinate is the oldest coordinate system. They should be go back to ancient Greek. Okay, this is populous there, right? We learned the polar coordinate from trigonometry 172 before. So here, we are going to deal with that with calculus. So first, that we're going to show how to graph sketch the polar curves using graph calculator. And what is the polar plane curve? Okay, we deal with the curve in the plane. Okay, two-dimensional. So what the definition? Let's go over a little. So in the polar coordinate system, do you remember coordinate system? We have two items. One is the angle, right? Another is the distance. We use r. Angle is theta. Okay, in the polar coordinate system, if we give equation, r is a function of theta, or generally we can say r and the theta has a relationship in the equation, and this equation we call the polar equation. Okay. And the paired points, okay, the point in the coordinate systems, r and the theta, and this pair, right? So a lot of pairs all put together we call the polar curve. So we can use the polar curve, we can use the polar equation to describe a polar curve in the polar coordinate system. So first, let me look at a remark. And the last topic we learned that the parametric curve, right? And the polar curve is a special type of parametric curve. So what the parameter? The parameter is theta. Why we say this? Because we learned this, right, from trigonometry. And we can link the polar coordinated systems to rectangular system, the Cartesian system. Relationship is here. X coordinate is r times cosine, and the y is r times sine. And the r is a function of theta. Can you see? So x is a function of theta, y is also a function of theta, which means a parametric curve, right? The parameter is theta. Okay. And let me look at the example. And if we're going to deal with the circle, remember how to deal with the circle? We have a lot of ways. Here we listed the 3 ways. How to deal with the circle? The radius is 2, right? In this case, the rectangular equation. If I say this is x axis, this is y, of course x squared plus y squared is equal to r squared, which is 4, right? Okay, and we have another. So now it's the polar equation. What is the polar equation? Okay, polar equations is all the points on the circle, and the distance to the origin, the polar, is 2, which means that the polar equation is r equals to 2. In this case, a circle is r equals to 2 with the radius of 2, right? And how about the angle? No matter the angle equals what? From 0 to 2 pi, the distance are always equal to 2. Super easy to describe in polar system, right? For a circle. And we just say a rectangular system equation is like this. And we say a polar curve is the specific, special type of parametric. Where the parametric? Can we look at it? The relationship x equals r. In our case, r is 2, so x equals 2 times cosine theta. Y equals 2 times sin theta. Theta belongs to 0 to 2 pi. And this is a parametric equation. Okay, and for these 3 types, we can convert between each other. We learned in trigonometry how to convert between polar equation and the rectangular equation. The basic relationship is use this information, right? We will not go back to that. Here we're going to graph. So how to graph? Let me look at how to graph. Okay, and here is basic steps. How do you sketch the polar curve using graph calculator? I will use Texas 83. Okay, if you have 84, it's the similar. Okay, the first setup mode to polar, POL. The second setup of polar equation, type of the equation to y equals. And the third we set up the window so we can see all the curve. And the last is grand graph. And the y compared to the parametric equation, we don't have the fifth step, which means trace to find the direction. And usually for the polar curve, we don't need to trace the direction. Why? Because the direction is easy, and the direction is from the angle, smaller angle, to the big angle. Angle tells you is counterclockwise, right? Okay, so we are going to see. Let's look at the one example here. I already draw the graph here. It looks like a heart, right? Definitely. So we call it this curve. We call it cardioid, and the polar equation here. If we're going to describe this user rectangular equation or the parametric curve, it's too complicated. If we use polar, it's super easy. And the distance equals 1 plus sine theta. Theta is the angle, okay? And so theta is from 0 to 2 pi, which means a circle. And we just said we don't need the fifth step to trace. Why? See, easy to look at. Okay, at the beginning is this point, right? Because what? Because theta equals 0. Theta equals half pi over 4, 45 degree go to here. Theta equals pi over 2 go to here. Theta equals pi go to here. Theta equals finally pi go to, this is 3 pi over 2. This is 2 pi, right? So just go to the counterclockwise. Okay, it's easy to look at direction. Usually we will not put the arrow to show the direction. Okay, and for us, so how do you use the graph calculator to get this graph? Can you see? And we're going to use my calculator to get the graph for you. And be patient. I'm going to set up my calculator. So here is my calculator. Okay, I use the Texas instrument 83. If you use 84, it's very similar. Okay, so we're going to see. So, and the first, we're going to remember the first step. And what do we need to do? We need to set up the mode, right? Remember the first step. Set up a mode to the polar. Set up a mode and go down. See, so far is a function. This is the parametric. This is the polar. Okay, set up this. And also for the angle, we use the radian. And usually in the polar system, we use a radian, not a degree. Okay. In our this question, definitely we use a radian. And we can see theta belongs to 0 to 2 pi, right? Use radian. And then the second step, what do we need to do? We need to set up the equation. Okay, set up a polar equation. The second step, how to set up. So we're going to y equals. Okay, I will going to type r is the distance. Our question is, you see, is 1 plus sine theta. Okay, so 1 plus sine. Whereas theta is there is the alpha beta 3. Parenthesis. Okay, this is the polar equation we are going to draw, right? For the third step, we're going to set up a window. So how to set up a window? Okay, let's going to look at the window. So let me tune a little so you can see it clearly. Wait. Yes, much better. How do you set up a window? Let's look at it. This is the equation. So first step was theta, the minimum, the maximum, 0 to 2 pi, no problem, 0. And the 2 pi is 2 pi, okay, go down. And the theta step does not matter, it's 0.1 or something. Okay, and the x minimum, x maximum, okay, it depends. X minimum, x maximum, the left limit, the right limit. This graph I already get. If you don't have the graph, how do you get the x minimum? From here, x is r times cosine theta. You can imagine r is this 1 plus sine theta parentheses times cosine theta. What's the minimum? R is from 0 to 2, right? R is from 0 to 2. Cosine theta is from -1 to 1. You can imagine. Okay, the possible minimum is -2. The possible maximum is also +2. Okay, so that means we can simply set up a -2. The first step at least, +2. This is from the equation. What the scale does not matter. Okay, or the scale you can say I will put a 1 as a scale. Okay, so we have 1, 2, 3, 4 points scale, right? Now is what the y minimum and the y maximum. Y is r times sine theta. You can imagine this, the minimum is negative 2, the possible minimum negative 2, the possible maximum positive 2 still. So I will set up a negative 2, 2, positive 2. Okay, later when we look at the window, you still can adjust, okay, modify your window later, don't worry. So now the step already set up. So the last is how to graph, okay. You can look at the scale, does not matter. Graph is here, the last step. Can you see? Okay, definitely we get the graph, right? Look, the window is not a very setup is not very good. What are we going to do? I will going to narrow a little bit of the window. Can you see? For X, probably from negative 1.5 to 0.5. Okay, I will narrow X from negative 1.5 to 1.5. And for Y, probably is negative 0.5 to 2. Okay, I will going to back to modify. This your graph looks better. Can we see? X, I will going to negative 1.5. Y, the X maximum is 1.5. Y going to negative 0.5. Okay, so that's all the modification, and then look at it. Can you see? Yes, this is the final. Exactly is similar as I showed you. Is a heart, right? This is a heart. That's all. Thank you.